When thinking about risk, you need to take into account the cost of failure and the cost of quality. The risk can be misunderstanding about the quality despite the various definitions that are in circulation. Quality of a process can mean the different things to many different people, but the quality is also not the same thing that has been assumed over time. When we look at different ways how failures occur, by first understanding what drives decisions around them determining what is the cost of quality, and failures and what happens when risk was not adequately determined. Take these two scenarios. First, consider an expensive process. One of the first questions when a quality improvement effort is proposed is, how much will it cost? The cost of failure is always a valid question, but an uninformed view can produce an invalid answer. Conversational wisdom, perhaps called conversational ignorance, in this case, has it that bit better quality cost more. The second is it could be an expensive product. This may be the most significant misunderstanding because the tendency to view quality is in terms of the product. An automobile with leather seats, a little mechanism that wipes the headlights costs more than one without those features. A fine writing instrument costs more than a plastic ballpoint pen. Nevertheless, price does not confer quality. Review the definitions of quality. None of them mention price. Quality arises from the ability to satisfy the customer's needs. If a customer's goal is to spend money, then an expensive product may not be viewed as the top quality. Customers generally seek the lowest price for a product that meets the fundamental needs, not the highest. Consider accuracy and maintenance. An inexpensive digital watch from a drugstore provides better quality than a more expensive mechanism watch from a jewelry store. A customer may want the jewelry item, but only because it serves a purpose other than the timekeeping, not because it's a better quality watch. Bringing back into maintenance and reliability, failures costs may result from either an internal or external failures. The significant costs associated with internal failures, which occur before the product has been delivered to the customer, and the scrap and rework could occur. At the end of some process, a product may not conform to the prescribed specifications. The degree of non-conformance may be so severe that the product cannot be fixed and must be discarded. Any costs associated with production to this point are lost and considerable scrap. In some cases, the degree of non-conformance may not be so severe. A reasonable amount of additional effort may bring the product into conformance, so the effort is re-entered into the process. And any other adds to the overall cost of production. This be called the rework. A failure mode effects analysis can work to prevent earlier in the process and alleviate some of the risk. The scrap and rework costs are more than the sum of the lost product and additional costs. Considering costs associated can be including the disposal, the storage, transportation, and inventory control determine total cost. Risk from external failures after the product has been delivered to the customer may generate costs for repairs following product warranty obligation. They may also cause product recall, which can be far more expensive. Consider the potential cost of fixing a defective part during the assembly versus recalling 1.2 million automobiles to replace a bad part. Recalls costs are orders of magnitude higher than repeat cost. The cost of human suffering and loss of life cannot be calculated, but courts will do their best. Resulting awards in compensation and punitive damage can be astronomical. External failures cause including those associated with complaints and complaint handling. Look at this example. In 2009, Toyota Motor Company faced one of the most expensive recalls in our generation. One of the most feared scenarios is a driver not being able to stop a car. After several car accidents, Toyota issued a large recall that nearly equaled the same amount of vehicles sold in the US car makers combined. In this case, it was determined that the pedals were sticking down to the ground. The pedals were made of a weak material that caused the pedal to crack, bend, or break. Preventive costs are fundamentally different from failure costs. These costs are related to things that an organization does rather than to the outcomes of the process. Prevention costs being with the planning. One of the most significant errors is to leap into the performance without significant planning. Planning may be limited for many reasons. Some of them are legitimate. Urgency may be a reason, but if your need for the product is so urgent that the product should be correct when delivered. Management's desire to cut costs may be a reason, but would management be willing to fund the efforts required to do the work and make it right if it was not delivered? Planning generates early costs, but good planning prevents late costs from changing to a preliminary plan. The cost of changes goes up as the project progresses. Changes made during the implementation are far more expensive than the changes made during the planning. Process planning establishes the steps to produce the product's projected finish. Process controls ensure that the process performances are expected. A well-trained workforce may produce defective products if the established procedures cannot have that high degree of conforming information or methods that tend to be that are static, but other things like material management, working conditions, tools, and requirements are all play a part in it. It can change things around. Processes must be monitored and analyzed to ensure that they are current with the organizational needs and not something that is done because it seemed like a good idea at the time. Process planning will cause an organization to incur costs for the plan and additional costs for control activities and the process improvement. Still, these costs will pay back in reduced defects over time. Product review constitutes another prevention cost. Customer coordination, requirements definitions, internal design reviews, and reliable engineering all generate early costs that contribute to the quality of the final product. To look at an example, we're going to look back at an article published in 2017 by the EHS Daily Advisor called The Cost of Catastrophe. The Chemical Safety and the Hazard Investigation Board, CSB, issued a report resurfacing 4 investigations. The first was the West Fertilizer Company, the Chevron Richardson Refinery, the Deepwater Horizon well blowout, and the BP Texas City Refinery. These investigations revealed both that the human and the financial toll of large-scale catastrophes. April 17, 2013, an explosion at the West Fertilizer Company in West Texas caused 15 fatalities and more than 260 injuries. It cost more than $247 million, including $16 million in federal disaster assistance and $230 million in insurance-related losses. Even worse, the company was issued only $1 million of insurance. August 6, 2012, an explosion at the Chevron Richardson Refinery in Richmond, California caused more than 15,000 injuries. It cost nearly $450 million. March 23, 2005, an explosion at the BP Texas City Refinery in Texas City, Texas killed 15 workers and injured 180 more. Financial losses to the innocent total of $1.5 billion. And finally, April 20th, 2010, an explosion aboard the Deepwater Horizon of the Gulf of Mexico left 11 workers dead and 17 injured. Employees paid more than $21 billion in settlements and more than $11 billion in economic and medical claims. That's almost as much as the entire budget proposed for the Department of Energy in 2017 by the US government. Worse, litigations remain ongoing in this case, and the settlements for the medical costs are uncapped and also remain an ongoing cost. When the cost of chemicals can be in the hundreds of millions or even in the tens of billions of dollars, it ought to be relatively simple to make a case for the prevention is for a more cost-effective option. A focus on risk and failure mode effects analysis can be a preventive tool to help mitigate and reduce these issues.